Hi everybody, so in this video we are going to cover algebra and function basics, which is chapter 1. Specifically, we are going to be working on part 1.1, which is equations and formulae. So we'll start with example number 1. Part A, it says solve for B in the formula. So the formula, a squared plus b squared equals c squared. Then we can say that b squared is equal to c squared minus a squared. Therefore, b is equal to plus minus square root of c squared minus a squared. Now here it's important to notice that we have to use plus minus whenever we solve for a square. You might say, yes, but this is the Pythagorean theorem. Well, they're not specifying that, right? If it were a triangle, if we were solving for a right triangle, then we would only use a positive value because obviously distances are only positive. In part B, they ask us to solve for L in the formula t equals 2 pi square root of L over G. What we have to do then is send the 2 pi to divide, so t over 2 pi is equal to the square root of L divided by G. We will have to square both sides to get rid of the square root. And then we're going to get, and I'm going to rearrange this, so it's going to be L over G is equal to t squared over 4 pi squared. And finally, we can say that L is equal to G times t squared over 4 pi squared. Okay, so now I'm going to erase this and we're going to do part C. So in C, they want us to solve for R in the formula M equals N times R over capital R plus small cap r. So here the difficulty might be that there's two r's, but you will see that this is not as complicated as it seems. So we can send this to multiply and we're going to get m times capital R plus small cap r is equal to n times capital R. And then here we can do distributive property. So we have m times r plus, that would be capital R, plus m times small cap r is equal to n times r. So they want us to solve for r. So what I'm going to do is that I'm going to bring the r's to the right. And I'll do it up here. So we can rewrite this as m small cap r is equal to n times capitalized R minus m times capitalized R. So what we do next is that we factor out R. And we get the expression R times n small m minus big cap M. And then finally, we can just say, well, R is equal to mr, m times R, over small cap n minus capitalized M. So now we are in example 1.2, and it says without using a GDC, you're going to see the GDC a lot in the textbook. It means graphing display calculator. Sketch the line that is the graph of each linear equation written in general form. So what it's saying is that these equations are written in the so-called general form. The general form is ax plus by plus c equals 0. So that's the general form. But if we want to sketch it, we probably want to use the slope-intercept form. Remember that the slope-intercept form is the one where you have y equals mx plus b, where m is the slope and b is the y-intercept. So what we have to do with letter A is rearrange it, right? So if we have 5x plus 3y minus 6 equals 0, we can rearrange this into 3y is equal to negative 5x plus 6, and then we can send the 3 to divide the whole expression. So we're going to get y equals minus 5/3 x plus 2. So notice that we already have one point, which is the y-intercept. We have the coordinate 0, 2. I like to get the coordinate of the x-intercept in order to graph the function. So we can do this by equaling the function to 0. So minus 5/3 x plus 2 equals 0. So for what value of x is y 0, that would give us the x-intercept. So if we rearrange this, we're going to have minus 5/3 x equals negative 2. And then we're going to get that x is equal to 6 over 5. So that means that 6/5 comma 0 is our x-intercept. And because this is a linear equation, we only need 2 points to be able to graph it. So if we graph it, we need 0, 2 as a point. That would be right here. And then 6/5 is a little bit over 1 on the x-axis. It's 1.25. So we would do 1, 2, and a little bit over here, 1.25. And then we can just draw the line. There you go. So that would be more or less the graph for letter A. So I'm going to erase this, and we're going to do the graphs for B and C. So for B, we have y minus 4 equals 0. And if we rearrange this, we're going to get that y equals 4. So this is a constant, right? This is going to be a constant. And at y equals 4, so the way to graph this is simply by counting 1, 2, 3, 4 on the y-axis and then drawing a line, a horizontal line. Now with C, we have something similar, but it's going to be a vertical line. As you can see, if we have x plus 3 equals 0, we can rearrange this as x equals negative 3, and this is going to be a vertical line at x equals negative 3. So 1, 2, 3, negative 3, and then we graph the line there. All right, so now we are in example 1.3, and part A says, find the equation of the line that passes through the point 3, 31 and has a slope of 12. So we have a slope of 12, m equals 12, and we have a point which is 3, 31. So if they give us a point and a slope, it's easy to use the point slope formula. Now the point slope formula says that if you have a slope m and a point x1, y1 on that line, on the line we're finding the equation of, we can write the equation as y minus y1 is equal to m times x minus x1. So with the data we have, we could write this as y minus 31 is equal to 12 times x minus 3. But because they want the equation, as it says here, write the equation in the slope-intercept form, we have to rearrange this, right? So we're going to get y minus 31 is equal to 12x minus 36, and this will be the same as y is equal to 12x minus 5. So this would be the equation in the slope-intercept form. So I'm going to erase this to do B. So for part B, they say find the linear equation and in C and F, knowing that C equals 10 when F equals 50, and C equals 100 when F equals 212. Solve for F in terms of C. Since they want us to solve for F in terms of C, that means that C would be our X and F would be our Y. So we can take these as coordinates. So when C is 10, F is 50. And when C is 100, F is 212. So we need, for this, we can use again the point slope formula. We have 2 points, but we don't have a slope, but we can find the slope, right? So the slope is equal to rise over run, or difference in y over difference in x. So in this case, it would be 212 minus 50 divided by 100 minus 10. And this is going to equal 162 over 90, which if we simplify is 9/5. So we have everything to rewrite or write the equation in the point slope way, and then we can rearrange it and leave it in the slope intercept form. So we're going to do, let's use the easier point, which is 10 and 50. So we can say f minus 50 is equal to 9/5, the slope, times c minus 10. And we're going to rearrange this, and we're going to get that f is equal to 9/5 c minus 18 plus 50. And finally, we're going to get that f is equal to 9/5 c plus 32. And that would be the uh, the linear function or the linear equation. Notice that this is the function necessary to change degrees from Celsius to Fahrenheit. And the previous problems are also related to physics. Very well, so now we are in example 1.4, and part A says show that the points P 1, 2, Q 3, 1, and R 4, 8 are the vertices of a right-angled triangle. So if we draw these points more or less, right, we make a quick sketch on a Cartesian plane. 1, 2, we could say it's over here more or less. 3, 1 would be around here, and 4, 8 would be around there. So we have to prove that these are the vertices of a right triangle. So this would be point P, this would be point Q, and this would be point R. So the way that you prove if those 3 points are the vertices of a right angled triangle is if their distances are a Pythagorean triple. So how do we do that? Well, we need the distance formula. Remember that the distance between 2 points, let's call 2 points x1, y1, and x2, y2. The distance between 2 points formula says that you can find it by the square root of the difference of an x, so x2 minus x1 squared, plus y2 minus y1 squared. So if we apply this, we would find the distance between 2 points. Now this is based on the Pythagorean theorem. In the textbook, you can see the proof. So what are our points? Our points P, which is 1, 2, then we have Q, which is 3, 1, and we have R, which is 4, 8. 4, 8. So if you do the math, you're going to find out that the distance PQ is equal to square root of 5. And you're also going to find that the distance QR is equal to the square root of 50. And finally, that the distance PR is equal to the square root of 45. So it's pretty easy to see that these 3 distances actually form a Pythagorean triple, where QR, being the longest length, would be the hypotenuse. So that means that PQ squared plus PR squared should equal QR squared. And this is obviously true because if you grab PQ, which is the square root of 5, and square that, and add it to PR, which is the square root of 45, square that, that should equal the square root of 50 squared. And this is obviously true because 5 plus 45 is equal to 50. Therefore, we have shown that the points are the vertices of a right-angled triangle. So now we're going to do part B. Part B says find the midpoint of the hypotenuse of the triangle. Now, how do we find the midpoint? Recall that the midpoint formula says that if you have 2 points, again, x1, y1, and x2, y2, the midpoint is found by simply adding the points or the x's, dividing by 2, adding the y's, and dividing by 2. So the midpoint between these 2 points would be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So this would be the coordinate of the midpoint. And because you want to see the midpoint of the hypotenuse, um, remember that the hypotenuse was QR. So we need to find the midpoint between Q and R. So Q, 3 comma 1, and R, which is 4 comma 8. So the midpoint of the hypotenuse would be given by 3 plus 4 over 2, comma 1 plus 8 over 2. And this is going to equal 7 halves, comma 9 halves, which then is the midpoint of the hypotenuse. And this was part B of example 1.4. Okay, so now we are on example 1.5, and it says find x such that the distance between points 1, comma 2 and x, comma negative 10 is 13 units. So for this problem, we definitely need to use the distance formula. So we know that if the distance is 13, then 13 has to equal the square root of x minus 1 squared plus negative 10 minus 2 squared. And from this, square both sides first. We're going to get this, square both sides. And we know that this is 144 because this will be negative 12. So we're going to get 169 is equal to x minus 2, or x minus 1, excuse me, squared plus 144. And we can simplify this and say, well, x minus 1 squared is equal to 169 minus 144, which is 25. So notice that this squared equals 25. So that means that this is either 5 or negative 5. So that means that x minus 1 is equal to 5, or x minus 1 is equal to negative 5. That means that x is equal to 6, or x is equal to negative 4. And those would be the two solutions.